Welcome to this Maths Made Easy video on grouped data. To start with, let's take a look at estimation from histograms. Since histograms collate data, it may seem impossible to answer questions like how many data points are greater than 9 unless 9 is a class boundary. We can, however, estimate the answers to these questions by assuming frequency is evenly distributed across an entire class. Here is how to do it. So for example, if we take a look at this example here, approximately how many values greater than 12 are in this histogram. So here, what we do is we go across the x-axis here, and we mark where 12 is. So this would be 6, 7, 8, 9, 10, 11, 12. So we know 12 is here. What we do then is we go up from 12, okay? So what we note here is that everything to the right of this 12 here, are values greater than 12. So if we split this now into two different parts, so if I just change my pen colour here, so we change this to red then, well, in this case then, if we shade the part on the left here with red, what we can see then is we're looking for everything here. So now, this second block extends from 12 to 20 and 20 to 30, okay? Now this extends from 12 to 20 with a height of 2. So in that case, we have a frequency of 2 times 8. So 2 times 8 here, which gives us 16. So the second block here gives us 16. And for this block here, the third block, this has a length of 10 and a height of 3. So that gives us 10 times 3, which gives us 30. So we know this block here gives us 30. So in that case, we just need to now add these two values together. So therefore, 16 plus 30 gives us 46. So in that case, that tells us there are 46 values which are larger than 12. So 46 values greater than 12. Greater than 12. Okay, so that gives us everything we need there for estimation from histograms. Moving on now to take a look at a frequency polygon. So a frequency polygon is another way to represent grouped data. It is a line graph joining the points with the following coordinates. So the coordinates here, our x coordinate is the midpoint of the class, which we can see here, and the y coordinate is the frequency. So we can note here the midpoint for each class. So the first midpoint here from 0 to 10, that will be 5. The next midpoint here from 10 to 18 will be 14. The next midpoint here will be 21. The next midpoint here will be 25. And finally, our final midpoint here will be 33. So in that case, our coordinates will be the class and the frequency. So for example, that would be 5, 9. The next one will be 14, 15. The next one here will be 21, 17. Our next one will be 25, 9. And finally, 33 and 4. And what we get here, if we connect these, or if we plot the points first and then connect these with straight lines, we get something that looks like this. So we can note here this is 5, 9. We can note here this point is 14, 15. This point here is 21, 17. This point here is 25, 9. And this point here is 33, 4. Okay, so we get something that looks like this. So that gives us everything we need there for frequency polygons. Moving on now to take a look at estimating the mean and standard deviation from a histogram. Previously, when we used frequency tables to find the mean and standard deviation, we looked at x, f of x, and f of x squared. While we clearly still have f, it's not so obvious how we should get x. And this is where the idea of midpoints comes in again. So to estimate the mean and standard deviation from a histogram, first turn the histogram into a table, then add a column of the midpoints of each class labelled x, and then create columns fx and fx squared, and find the totals of all of the columns. Finally, we use these totals in the formulas for the mean and standard deviation. So recall here the following formulas. So for the mean, we use sigma fx over sigma f. Okay, so that's our formula there for the mean. For the variance here, so for the variance, this is given as sigma fx squared over sigma f, and we minus the mean squared, so minus the mean squared. Okay, and finally for the standard deviation, so for the standard deviation here, this is equal to the square root of the variance. Okay, so that gives us everything we need there for estimating the mean and standard deviation from a histogram. And finally, let's take a look then at estimating the median from a histogram. So, to estimate the median from a histogram, we use linear interpolation. This is where we assume that within each block, the frequency is evenly spaced. To find the median, first find sigma f and divide it by 2 to find the position of the median. Since this is an estimate, if we obtain a decimal, we can treat it as if it is a whole number position. Then find which block the position falls into. Then within that block, find where it lies. So for example here, if the median is the 7th position of a block with 10 values of length 5, then you would add 7 times 5 over 10, which is equal to 3.5 to the lower bound of the block to find the median. Okay, so that gives us everything we need there for estimating the median from a histogram, and that concludes this Maths Made Easy video on grouped data.